Okay, we're looking at MyiMaths quadratic inequalities. Question 1. So first inequality, x squared minus 4 less than or equal to 0. So let's just get onto my notepad. X squared minus 4 less than or equal to 0. Well, x squared minus 4 will factorize as x plus 2 times x minus 2, because we've got no x's and minus 4 on the end. So for a quadratic factorization, we're looking for factors of 4 that add up to 0, and factors of minus 4, I should say, that add up to 0. So 2 times minus 2 makes minus 4, so that's your factors of minus 4, and they add up to 0. Also, anything with x squared minus a square number is a standard factorization of plus and minus the square root of the square number. So that is a kind of standard one you can recognize. But in any case, x plus 2 times x minus 2 is less than or equal to 0. Well, let's do a nice number line. Try and do this as straight as I can without resorting to the ruler tool. And let's think about the values that would make that equal to 0. So, you've got 0 in the middle of the number line, minus 1, minus 2 there, 1 and 2 there, and other numbers. So when either of the brackets is 0, then the whole thing will come to 0, because any two things multiplied together will be 0 if one of them is 0. So for example, when x is 2, that will make this bracket 2 minus 2 equal to 0. So I'm just going to put the point x equals 2 on my number line. And then the other bracket will be 0 if x is minus 2. X plus 2 will be 0 if x is minus 2. So having identified the points where the whole thing is equal to 0, we now need to think about the range of values that will make the whole thing more than or less than 0. So let's think about a really big number up here. Let's say x is 100. So up there, when x is 100, you would get 102 times 98, which is definitely a positive number. So that wouldn't be less than 0. So that's not in the range that we want, because we want it to be less than 0. We want it to be negative, in other words. Let's now think about all the way down here when x is, say, minus 100, a really big negative number. When x is minus 100, you would get, so the first bracket would be minus 98, and the second bracket would be minus 102. So you'd get minus 98 times minus 102, minus times minus, and that would be a plus. So down this end of the number line, you'd get the whole thing being positive. So at the top end here, you get a big plus times a big plus gives you a positive number. At the bottom end here, you get a big minus times a big minus gives you a positive number. At the 2 points I've identified, 2 and minus 2, the whole thing is exactly equal to 0. So it's only in between those 2 points where you get one of the brackets being positive and one of the brackets being negative. So it's only between those 2 points that x squared minus 4 comes out to be less than 0. And we can check that. Let's just take a value here, 1 for example. When x is 1, you get 1 squared minus 4, which is 1 minus 4, which is less than 0. Okay, so the number line there has helped us identify the range of values of x for which the original inequality is 2. So the inequality is true between -2 and 2, between x is -2 and 2. Let's just label that as x. And it's a less than or equal to inequality. So that means we would fill in the circles on the number line to say that it's allowed to be equal to 0. And then back over to my iMaths. Okay, so the range of values for which the first inequality is valid is between -2 and 2. So I'll just fill in between -2 and 2. X between -2 and 2 makes the inequality true. Okay, well, let's go to the next one to the right of that. X squared minus 121, this time greater than or equal to 0. Okay, so I'll go back to my notepad there, just move that out of the way. So x squared minus 121 greater than or equal to 0. Well, again, that's a standard factorization. X squared minus a square number, and it factorizes as x plus 11 times x minus 11. And we want it to be greater than or equal to 0. So again, let's think about the number line. You've got 0 in the middle. So these are values of x, and at 11 and minus 11, the whole thing is equal to 0, because those are the values that make the brackets equal to 0. Let's think about a very big value up here. So when x is, let's say, 100, then you would get 111 times 89. So that's a big positive times a big positive, and that definitely would give you something that's more than 0. So the inequality is certainly true when x is greater than or equal to 11. Let's think about some really big negative values. So for example, when x is minus 100, down there somewhere, well, if x was minus 100, then you would get x plus 11, that would be minus 89, times minus 111. So you'd get a big negative by a big negative, and a negative times a negative gives you a positive, so it would be more than 0. So in other words, this inequality is true if x is more than or equal to 11, or less than or equal to minus 11. So let's just go back to the MyiMaths. Okay, so x less than or equal to minus 11, or more than or equal to 11. Okay, on to the next one. X squared plus 11x plus 24 less than or equal to 0. So let's just go to my pad here. X squared, I've forgotten what it said. Getting lost on my device here. Plus 11x plus 24 less than or equal to 0. Plus 11x plus 24 less than or equal to 0. Well, let's try and factorize that. So that quadratic factorized, well, we're looking for factors of 24 that add up to 11. So two numbers that multiply together to give 24 and add up to give 11. Well, you could do a whole list of the factors of 24 systematically. 1 times 24, 2 times 12, 3 times 8. I'm kind of used to these, so I can spot very quickly that it's going to be 3 and 8. So x plus 3 times x plus 8 is the factorization. And the values that will make it exactly 0 are when x is minus 3, so that the x plus 3 bracket comes out to be 0. Or if x is minus 8, so that the x plus 8 bracket also, instead comes out to be 0. So let's think about that on a number line. If x is -8 or -3, there's x there, then the whole thing will come out to be exactly 0. So let's think what happens in between and on the other side of that. So up here, say if x is 100, if x is 100, then we would get 103 times 108, which is a very big positive number. That's not going to be less than 0. So above -3 or to the right of -3 doesn't work. Let's think about what happens to the left of -8. Well, again, let's think of a very big negative number. Let's think of -1000 this time. So -1000 would give me -997 times -992, which would be a very big negative times a very big negative, which would give a very big positive. So that definitely wouldn't be less than 0. So it must be in between -8 and -3 that the inequality is true. And let's think of a value in between. Let's think of, say, when x is -5. When x is -5, you would get -2 times 3. You'd get one of the brackets being positive and one of the brackets being negative. So a positive times a negative would give you a negative, and the whole thing would be less than 0. So the range of values that satisfies the inequality is when x is between -3 and -8. So let's just go back to MyiMaths. X has got to be between -3 and, it should be the other way around, shouldn't it? Because -8 is less than -3. So x has got to be between -3 and -8. More than -8, but less than -3. Let's just check I got that the right way around on that number line. Yes, I did. Okay, so I'm happy with that. Question 4. X squared plus 10x plus 9 greater than or equal to 0 this time. X squared 10x 9. Let's just write that down. X squared plus 10x plus 9 greater than or equal to 0. So this one factorizes with 9 and 1. So two factors of 9 that add up to 10 give you 9 and 1 in the brackets, x plus 9, x plus 1. So with the factorization, x plus 9 times x plus 1 is greater than or equal to 0. And just at this moment, I'll check I'm still recording. Yes, I am. Panic moment there. Greater than or equal to 0. So for it to be equal to 0, x would have to be -9 or -1, so that the brackets came out to be, either of the brackets came out to be equal to 0. For a very big value of x, again, let's think about 100. So if x was 100, you'd get 109 times 101. So that's definitely more than 0. And for a very big negative value, let's think of -1000. If x was -1000, you'd get -991 times -999. So you'd get a very big negative times another very big negative, which would give you a very big positive. So that would definitely be more than 0. So it looks like the inequality is satisfied above -1 or below -9. Let's just think about what happens in between, say at -5. So at -5, if x is minus 5, you get 4 times minus 4. So a positive times a negative would give you a negative, but we want it to be greater than 0, so we want it to be a positive. So on this occasion, the inequality is satisfied if x is greater than minus 1, so in other words to the right of minus 1 on the number line, or if x is less than, or equal to, I should be saying, minus 9, to the left of minus 9 on the number line. So over to my MyiMaths, let's fill in x has got to be less than or equal to minus 9, but greater than or equal to minus 1. Okay, well, these are starting to get a bit samey now, but let's just have a look at this one now. X squared minus 12x plus 27. So let's just move that out of the way. X squared, I've forgotten what it was already, minus 12x plus 27, and we want it to be less than or equal to 0. So the factorization of this one, well, it's going to involve negative numbers somewhere, isn't it? But to make a plus 27 on the end, it's got to have a minus times a minus to make a plus, and get negatives somewhere involved. So it's going to be an x minus something and an x minus something. So we just need to think about numbers that would multiply to give you 27. There's not actually very many to think of, and 3 and 9 does it. So the factorization is x minus 3 times x minus 27. Minus 3 times, times my, let me say that again, x minus 3 times x minus 9. So minus 3 times minus 9 give you plus 27. And minus 3 together with minus 9 add up to the minus 12. So that's your factors of 27 that add up to minus 12. So we want that whole thing to be less than or equal to 0. So again, let's think about the number line and the numbers that will make it exactly equal to 0. I'm going to stick x equals 0 there. Well, when x is 3, then this bracket will come to 0. When x is 9, this bracket will come to 0. So the whole thing will be 0 at 3 and 9. Let's think about very big values. If x is 100, then you'd get 97 times 91. So that would be a very big positive number, and it wouldn't be below 0. So we're not interested in numbers above 9. Just get rid of all of these things. Let's think of very big negative numbers, like minus 100. So if x is minus 100, you get minus 103 times minus 109. And that would be a negative times a negative, so that would give you a positive. And we don't want it to be a positive because we want it to be less than 0. So it's got to be in between the two where the inequality is satisfied. Let's think of a random value in between. So, for example, when x is 5, you'd get 2 times minus 4. So a negative times a positive would definitely give you a negative, so it would be below 0. So generally speaking, the inequality is satisfied between 3 and 9. So if x is more than 3 or less than 9, then the inequality x squared minus 12x plus 27 less than or equal to 0 is true, is satisfied. Okay, so x between 3 and 9, let's fill that in on the MyiMaths. 3 and 9. Okay, so let's zoom back out. And finally onto the last one. x squared minus 14x plus 40 greater than or equal to 0. Okay, so onto my pad. X squared, was it minus 14x plus 40 greater than or equal to 0? Let me just double check that. Yes, it was. Okay, so factorization. Well, to get a plus 40, it's got to either be a plus times a plus or a minus times a minus. To get a minus 14, there's got to be minuses somewhere. So it's going to be an x minus something and an x minus something in the brackets. So we want factors of 40 that add up to minus 14. Well, I can quickly spot that that's going to be 4 and 10. So minus 4 times minus 10 gives me the 40. Minus 4 plus minus 10 gives me the minus 14. So we want x minus 4 times x minus 10 to be greater than or equal to 0. Let's draw a little number line and think about the values that will make it exactly equal to 0. Well, if x is 4, then the first bracket will come out to be 0. If x is 10, then the second bracket will come out to be 0. For a very big value, like, well, let's go 1,000 this time, you'd get 996 times 990, which is two big positive numbers multiplied together. So that definitely would be greater than 0. Okay, so the whole thing is certainly true if x is greater than or equal to 10. 10, I meant to say there. And then let's think about down this end. So let's think about when x is minus 100. When x is minus 100, you get minus 104 times minus 110. So two very big negatives multiplied together would give you a positive. So the whole thing is certainly true when x is less than or equal to 4, because a negative times a negative would give you a positive. It would give you something that's greater than or equal to 0. Let's just check it doesn't work in between. So let's say when x is 6, 6 is a bit lower down than that, isn't it? Never mind. But when x is 6, you get 2 times minus 4, which would be a negative. So in between 4 and 10, you'd get one positive bracket and one negative bracket multiplying together to give you a negative. So the whole thing wouldn't be greater than 0 as we require it to be. So the solution to our inequality is that x has to be less than or equal to 4 or more than or equal to 10. Let's just fill that in on MyiMaths. So 4 there and 10 there. Let's just zoom out of the whole thing and mark it. There we go.